In this video, we are going to look at integrating a rational function. Remember, a rational function is a polynomial over another polynomial. So this technique is going to work only if there is a single term down here in the denominator. If you have more than one term down there in the denominator, then there are different methods, and it's generally going to be a more complicated problem. All right, so looking at this rational function, it is essentially the division of two polynomials. So it's a quotient, right? The thing is that there is no quotient rule for indefinite integrals. And so what we're going to have to do is to make this not a quotient. All right, and the way that we are going to make it not a quotient is to split this polynomial up over its denominator. Good. All right. So I'm going to take each term on the top and put it over the term on the bottom. All right, so take 4x to the fourth, put it over 9x squared, the 3x cubed, and put it over 9x squared, the 5x squared, put it over 9x squared, and so on and so forth. All right. And so then, because this denominator only has one term in it, then I am going to be able to simplify each of these terms out. And they're going to be a constant multiple of a power function. And so that means we can fall back on the constant multiple rule, the sum rule, and the difference rule, and the power rule to do this integration. So because there's no quotient rule, right, for indefinite integrals, for right now in Calculus 1, this is the approach that we are going to have to take. All right, so now I am going to simplify these with the constants. I am going to write those as fractions on the front. So I'm going to write this as 4/9. And then x to the fourth divided by x squared is going to be x squared. So this term reduces down to 4/9 plus x squared. All right, and I'm going to do that for each one of these terms here. So 3/9 is 1/3. X cubed divided by x squared is just x. All right. On this one, I just get 5/9. On this one, I have 2x over 9x squared, right? So again, I'm going to write that 2/9 out in front. And when I reduce this, I have x over x squared. That is going to be 1 over x. Because 1 over x, right, is the only power function that the power rule doesn't apply to, I'm just going to leave it like this. I'm not going to make any further simplification, right? Because we all know that 1 over x is equal to x to the minus 1. Normally, you would want that for almost any other power function. You want it written as x to some number of power, but this is the only one, right? Only power function for which the power rule for indefinite integrals does not work, okay? So I'm going to leave it as 1 over x. All right, the next one is going to be 7/9 times 1 over x squared dx. All right, and on this one, 1 over x squared, right, I do want to write that 1 over x squared is going to be the same as x to the minus 2. And so I would prefer for 1 over x squared to be written as x to the minus 2, okay? Because then I can use the power rule for indefinite integrals to take the indefinite integral. So that's what I'm going to do. I'm going to go back and I'm going to rewrite this as x to the minus 2. Like so. Okay, and so now I am ready to take the antiderivative of this. We could take the antiderivative of this form just by using constant multiple rule, sum rule, difference rule, and power rule. And so that's what we're going to do. So again, for the time being, in Calculus 1, if you have a product or a quotient that looks like this, the best thing to do is to make it not a quotient by splitting it apart over here. Okay, this may look a little bit unusual to you, but if you just remember how fractions are added or subtracted, right? If fractions have a common denominator, like all of these fractions do, then I would just combine the numerators and denominators, right, and put it over the common denominator. So this expression here is exactly the same as this expression. All right, so now we are ready to go. All we need to do is, because of the sum rule and difference rule, don't need that integral sign anymore, is to integrate each piece and then add or subtract them together. So starting with this one, I have a constant multiple rule, that 4/9 times x squared. The constant multiple rule says rewrite the constant and multiply by the indefinite integral of the function part. The function is x squared. That's a power function, so I'd use the power rule, add 1 to the power, and divide by the new power. So 2 plus 1, it gives me 3, and then I can put that as x squared over 3 or 1/3 x cubed, however way we want to. Next, the sum rule says put a plus, and then here on this term I have another constant multiple rule. So it's going to be 1/3 times the indefinite integral of x, which is going to be 1/2 x squared. Next, the sum rule says put a plus, and then I need to take the indefinite integral of 5/9. 5/9 is just a constant, right? So its indefinite integral would be 5/9 x. You can think of that as 5/9 times 1 if you like, right? And the integral of the one part would be x. But clearly, right, the derivative of 5/9 x is 5/9. All right, next up I have, again, on this term, 2/9 times 1 over x, I have a constant multiple rule. So I'm going to rewrite that constant 2/9, and then I'm going to multiply by the indefinite integral of 1 over x, right? That is going to be the natural log of the absolute value of x. All right, remember, that's the same as x to the -1. That is the only power function for which the power rule for indefinite integrals does not work. So it has its own rule. All right, next up is this last piece right here. Again, using the constant multiple rule, I'm going to rewrite the constant 7/9 and then times that by the indefinite integral of x to the -2. So that is a power function, right? And so I'm going to use the power rule. So the power rule says add 1 to the power. So -2 plus 1 is -1. And then divide by the new power. So I need to divide by -1. Dividing by -1 is the same as multiplying by -1. So I'm just going to put that there. Make sure that if you don't, you're careful not to confuse that as subtraction. So either put the times sign or parentheses here. I did both just to make it as clear as I possibly could that that wasn't subtraction. All right, and then I'm done with the integration part, and so don't forget your plus c, your constant of integration that goes on the end over there. All right, so we're done integrating now. Now it's just a little cleanup, and we just need to simplify this as much as possible. So here I have 4/9 times 1/3, that's going to be 4/27 x cubed. 1/3 times 1/2 is 1/6. Nothing to do with that piece. It's just 5/9 x minus 2/9 times the natural log of the absolute value of x. All right, on this one, I am going to multiply that -1 and the 7/9 and write that as -7/9, and then x to the minus 1, right, plus some constant c. You may also see that rewritten back as 1 over x, but usually I will just, on these indefinite interval problems, I will just leave it as x to a negative number power. So it just depends on where you look. Sometimes you'll see that written as 7/9 times 1 over x, or 7 over 9x, or like this. Okay? All right, and that is it for this problem.